All right. So hello, welcome, and thank you for joining me for our Zoom meeting for our Test 1 review. All right. So let me go ahead and share my screen. I sent you an announcement with the PDF file we'll be going over today and also the link to the Zoom meeting. So in case you want to have that handy so you know what we're talking about. Okay. So I'm sharing my screen, and before I begin, I always like to start off by reminding you that I have two different devices so that I can share a screen and also so you can see me as we're talking through Zoom. At any moment, if you have any questions, please unmute yourself. So I have you all muted so that we don't hear any background noise or I don't know. So there aren't little noises hovering through the lecture. But if you have any questions at any moment, feel free to unmute yourself at any time. Also, if you're shy to speak, that's okay. I'm kind of Zoom shy too during meetings. Feel free to use the chat option at the bottom. So if you move your mouse around or touch your screen, you see a little chat, or if you don't see it, you'll see an ellipsis so that you have more tools at the bottom. And at the ellipsis, you'll see that chat option. At any moment, feel free to type in your question via chat, and I'll be there to check it out. So just so you know where your chat is, I just sent a little chat. Maybe you'll get a little icon that says that you have something in the chat. All right, so we're gonna have a test. Our test 1 is going to cover chapters 1 and 2. Notice we only covered 2 sections from chapter 2. I didn't want to spend too much time online since there's more other content we have to get to. So it's going to be on chapters 1 and 2. You have a whole week to complete it. So it's due a week from today, which I believe is October 1st, 2nd. My calendar is all over there. So you have a week. So it's due a week from today, Friday. Your exam is multiple choice. And honestly, this is your exam, different numbers. Okay? So if you understand what we're doing today and know how to approach the question, you're in good shape. For your exam, you'll be given 2 attempts. In case you're test shy, that first one doesn't have to count, and that second one will count for sure. Out of those 2 attempts, your highest score is the one that will be recorded. You'll be given 2.5 hours to complete your exam. Typically, a class time would run maybe an hour, 50 minutes, and that's how much time you would have for the exam. But because we're not in a quiet classroom, you're at your house that's very much alive with your family members and other people. I know distractions are sometimes inevitable, so I do give you a bit more time just in case something happens and you have to walk away from your screen. All right, any questions about your exam before we begin our review? Alrighty, I'll go ahead and start the review. At anytime if you have a question, unmute yourself or use a chat box. Thank you for actually saying no questions. Or if you forget and something pops in your head, feel free to email me. I am here to help you. I won't know something is wrong unless you tell me. So email me. Let's go through these problems. Now again, these problems are just like your exam. Problem number 1, specify the domain of the function. So when we see the word domain, that means, in other words, your x. What can x be? The only time we have issues with the x is if we have a fraction, because we can't have a 0 in the denominator. And radicals, I can't take the square root of a negative. We learned that, yeah, we can, and we get an I, but unless we're working with complex numbers, imaginary numbers, we're working with real numbers, and that I doesn't live in the real space. So for this one, we see that the numerator is okay. There's no square roots. but that denominator, it can't equal 0. So we need to find out when it is equal to 0, because that's going to be a problem in our domain. All right, so we have x squared minus 1 is equal to 0. We can factor this to get x plus 1, x minus 1 equals 0. And we set each one equal to 0. So x plus 1 equals 0, x minus 1 equals 0. You get x equals -1, x equals +1. So that means x can't be -1 and x can't be 1. So which one of these answers fits our conclusion? A works, right? Okay, so that's number 1. Number 2 is very similar, but we're adding an extra argument. So for number 2, we see that we have a denominator. Again, our problem here is it can't equal 0. So we need to find out when those values are equal to 0 and set them to not equal 0. Our numerator, in this case, is also a problem. I can take the square root of 0, we get 0, but I can't take the square root of a negative number. So I have to set whatever the radicand, your argument on the inside, whatever that is, I have to set it equal to greater or equal to 0. Okay, so let's do those 2 problems. So I have x plus 7. I want to write it to be greater or equal to 0. All right, so then I subtract 7, I subtract 7. I get x is greater or equal to -7. All right, now my denominator, I need to set it equal to 0 to find out when it is equal to 0. So I have x plus 2 is equal to 0, and x minus 4 is equal to 0. Let's go ahead and solve. Minus 2, x is equal to -2. Plus 4, x is equal to 4. Let's go ahead and set them to not equal to, because those are numbers that would give us a problem. So which one of our answers matches all of our arguments that we just came up?
Answer A.
Answer A. Thank you.
Yep.
So those are the domain questions you'll see. Number 3, graph the line described through -1, 9 with an undefined slope. This one's tricky because it's asking you to recall what it is when we have an undefined slope. Well, those funny slopes are, if I have a slope of 0, we have a horizontal line. If I have a slope of undefined, we actually have a vertical line. I'll try to not write so sloppy, I'm sorry. Okay, so we have a vertical line. When we have a vertical line, we always get x equals a number. So I need to have a vertical line at x equals a number. So if I have the point -1 up 9, so we're here. If I have a vertical line, because it's telling me that I have an undefined slope, then I have a vertical line at exactly that point. Right, -1, 9. So to write the equation, it would be x equals what? Well, we see that we're at x equals, even here, we have x equals -1. So even if you're looking at this problem, you're like, whoa, I know it's a vertical line, but how do I come up with that equation or that line that I'm working with? Plot your point. And from that single point, extend your vertical line. So now let's look at our options. We see that A is the one that matches our solution. Number 4, Determine whether or not the function is one-to-one. Okay, well, one-to-one is a special type of function. So first, it needs to be a function, and it needs to be a function where your x's and your y's don't repeat. For every one x, there's a corresponding one y. So x's and y's do not repeat. Whoa. Now, if I have this picture here, is there a way that I can test this one-to-one function? And yeah, we can. We can do it by the vertical line test, a combination with the horizontal line test. So the horizontal line test tells us that this function is one-to-one. But the reason why I mentioned the vertical line test is because for it to even be a one-to-one function, it first needs to be a function. Kind of like how your thumb is a finger, but not all fingers are thumbs. That's kind of how that works. So it actually needs to pass both the horizontal, it needs to pass both the vertical line test and your horizontal line test for it to be one-to-one. So we see that once we use our horizontal line test, it fails. It fails because we crossed it at 2 points. So because of this, we say no. Our function is not one-to-one. Question number 5. Find f of 2 when f of x equals x squared minus 3x minus 4. All right, this question is using function notation to tell you plug in 2. So let's go ahead and plug in 2 to our function. So we have f of 2 is equal to 2 squared minus 3 times 2 minus 4. All right, what do we get? Well, 2 squared is 4, 3 times 2 is 6, minus 4. All right, well, 4 minus 4 is gone. We're left with only negative 6. So our answer for this one would be C. I think that's the first non-A answer we have gotten so far. So no, you shouldn't expect your exam to be all A's. That's just what happened. Number 6, use a graph to evaluate the function value. Okay, so we're given f of negative 1. So if we're saying that if my x is negative 1, remember we always have x comma y, what is your y? What is that y number? Well, all we have to do is take a closer look into our function, and negative 1, we see it ends up being maybe about, it's negative 1, right? Negative 1 is about 1, 2, 3, 4, maybe 3.5. I think 3 would be a closer answer, right? Oh, my x is trying to trick you with your x. So if this is 2.5, then this is 0.5, this is negative 1, negative 1.5, negative 2. So they're going by 0.5s. So this right here is negative 1. So we see that my answer is negative 5. Ooh, that was a tricky one. So for my answer for this one, it's negative 5. In other words, what it's saying is, what is that corresponding y? I always think these are like silly questions, But you see questions like these a lot when you get to like calculus and you're working with limits. You have to see where is that corresponding y. Number 7, use the definition of inverses to determine whether f and g are inverses. So we learned that inverses mean that they're exactly mathematical opposites. So we need to show that these two are opposites. To do so, we use composition. So that composition of f of g equals x. Also, we should also get that composition of g of f of x is also equal to x. So what do? We need to take our function f, and we need to take our function g and use composition. So this is equal to f, and for every function in f, I'm going to plug in g. So what we're saying is, if we're taking our function g, I'm going to take that and plug it in for every x, which is only once. So let's go ahead and do that. This gives me 2 times, and instead of x, I'm going to write your entire function g. So I have x plus 2 over 8, and then minus 8. So that's my 2x minus 8. All right, let's go ahead and clean this up. Well, I need to distribute this 2 into my problem. Maybe I should write that 2 as a fraction, so that I have 2 over 1 times x plus 2 over 8, and then subtract 8. Okay, so we see that this would be 2 times x plus 2 over 8 minus 8. We distribute that 2, so that we get 2x plus 4 over 8 minus 8. Well, the whole goal is to try to clean it up. I need to be able to add these fractions. So let's go ahead and multiply this 8 over 1 by 8 over 8 so that I can get a common denominator. All right, by doing so, we're left with 2x plus 4 over 8 minus 8 times 8 is 64 over 8. Okay, now that we have common denominators, let's go ahead and add. So I have 2x, and then we get 4 minus 64 gives us negative 60 over 8. Okay, and can we clean this up a bit more? Well, I can go ahead and maybe simplify these fractions. So this 8 simplifies both of these. But no, we see that our answer is not x, which is what we're looking for. So 2 over 8, that gives us 1 over 4x. And 60 over 8, that gives us 15 over 2, which is not x. Since it's not x, we say no, they are not inverses. All right, number 8. Define the slope and the y-intercept. Okay, well, we learned that by the equation y equals mx plus b, I can easily pick out your slope and your y-intercept. Your y-intercept is always that b, and your slope is always a number next to x. So what we have to do to be able to pick out the slope is to solve for y. Okay, let's go ahead and solve for y. We have 4x minus 5y plus 5 is equal to 0. So we want to get y by itself. Let's just move that 1y over. So plus 5y plus 5y. So that we have 4x plus 5y is equal to, plus 5 equals 5y. There we go. All right, last bit. We want to get y by itself, so let's divide by 5. 5 divided by 5 is 1. And we're left with y is equal to 4 over 5x plus 5 divided by 5 is 1. Okay, so which one matches our answer? We have a slope of 4 over 5, and we have a y-intercept of 1, 0, 1. And we see that C is our desired answer. And if you'd like to, you can always take a screenshot of the problem as they're working through it. Okay, there aren't any objections. Let's go ahead to number 9. Number 9, find the equation of a line containing the given pair of points. So I have 2 points, -5, -2, and -6, 2. So if I wish to find the equation of a line, I first need to start off by finding the slope. And once I find the slope, we can go ahead and use our point slope formula to find our equation of a line. Point slope formula. All right, so our slope is y2 minus y1 over x2 minus x1. It doesn't matter which one of your point you label as x1, y1 or x2, y2, as long as they're consistent with those 2 points. So I like to label them, otherwise I tend to make silly mistakes. So we have x1, y1, x2, y2. Let's go ahead and work it out. y2 is 2 minus y1, -2, divided by x2 is -6, x1 is -5, so minus -5. All right, in our numerator, we have those 2 negatives, which gives us positive. We're left with 4. And the denominator, -6 plus 5, -1. 4 divided by -1 gives us -4. This is our slope. Now we need to go ahead and try to create an equation of a line. For that, we're going to use our point slope formula, which is y minus y1 is equal to m times x minus x1. What we have to plug in is our y1, our slope, and our x1. Well, we already have our slope here. Now I just need to work with one of our points above. Doesn't matter which point it is, as long as you work with one of them. All right, I'll stick with that x1, y1 just because I labeled it that way. So I have y minus y1. y1 is -2 is equal to m, which is -4, times x minus x1. x1 is -5. Let me clean up those negatives. So I have y plus 2 is equal to -4, x plus 5. Okay, let's distribute that -4. So that we have -4x minus 20 and y plus 2. Let's go ahead and subtract 2 to both sides. So we have y is equal to -4, oh, I forgot that x, -4x. And negative 20 minus 2 gives us negative 22. Oh. Okay, now we're just left to see which one matches our answer. So y equals negative 4x minus 22. And we see that A is our answer. You see how it kind of tries to trick you? If you look closely at these numbers, at A, B, and C, and D, you see that it's the same numbers, but they try to trick you in the slightest way with positives and negatives and switching the order around. Okay, number 10, find the slope of the two given points. Y2 minus Y1 over X2 minus X1, that's your slope. Y2, relative our points, X1, Y1, X2, Y2. Our Y2 slope, our Y2 point is 5 minus Y1, negative 4, divided by X2, 8, minus X1, 3. And then we work out this fraction. So we have those two negatives, which gives us 5 plus 4, we get 9, and 8 minus 3 is 5. So we're looking for a 9 over 5. Our answer is B. (11) Graph the line described. So we want to use a point and the slope to create our line. So we first want to start off with your point. So our point is 0, negative, well, not negative, 0, 2. So I find my point 0, 2, it's right here. And then you want to use your slope. So our slope is 1/3. Remember, it's always rise over run. So this means I'm going to go up 1 and I'm going to go to the right 3. All right, let's take a look. So I'm going to go up 1 and to the right 3. 1, 2, 3, so that we're here. Those two lines together will create, those 2 points together will create our line. I hope your line looks a lot better than my line. But here you show you how you used your rise of 1 and your run of 3. All right, which one matches our graph? And we see that C is the one that closely resembles our graph, right? And notice how it tries to trick you. It kind of looks the same. So maybe instead of using the y-intercept, you try to use it as an x-intercept, or if you mess up your slope so that it's backwards, it knows how to trick you. So be very, very careful. All right, next question. The given graph represents the translation of the graph of y equals x squared. Write the graph of the equation. No, write the equation of the graph. So we see we have a parabola, y equals x squared, and there's a shift. So your shifts work this way. Let me give you a quick rundown of shifts. To begin, let's talk about the h's. If it's a plus h, you're going to shift however many numbers. I know we see plus, so we think right. For horizontal shifts, this kind of switched. So this would be left. From minus k, I would move right. I meant to write h, not k. Now for your k represents a vertical shift. So if I have a plus k, I move up. If I have a minus k, I move down. That A represents a compression or a stretch. If I have a fraction between 0 and 1, then it's going to get wider. That's called a vertical compression. If I have a number bigger than 1, it's going to be a stretch. And lastly, if there is a minus, then we'll have a reflection over the x-axis. And that's your shifts in a nutshell. Okay, so we see that this graph is moved over to the right. The right, how many numbers? We see we have 1, 2, 3, 3, right? So we have this peak, which is supposed to be here, and we can see that it switched over 3 units. So which one represents that horizontal shift? Right there, right? We're going to see that change within the parentheses. And because we move to the right, I should see a minus. So we see which represents a minus with a 3 inside the parentheses. And we see that it's D. D gives us that horizontal shift 3 units to the right. All right, number 13. Find g of a plus 1 when g of x equals 1 over 5x minus 3. So all this is saying is, let's plug in a minus 1 and simplify as much as you can. Okay, so by doing so, we're left with 1/5 times a plus 1 minus 3. Let's clean it up. So let's distribute that 1/5. So we're left with 1 over 5a plus 1 over 5 minus 3. Last bit we can do is combine like terms. So I can combine like terms with that 1/5 plus 1 plus 1/5 minus 3. Now to add and subtract fractions, we need to get a common denominator. So we need to multiply that by 5 over 5. So that we're left with 1/5 a plus 1 over 5 minus 15 over 5. Combine like terms. We're left with 1/5 a minus 14 over 5. Now that I've got a common denominator, I can write them under that same denominator 5. So then I'm left with 1a, or just a, minus 14 over 5. Which one matches our answer closest? So we see that, it kind of tries to trick you, right? You see those same numbers. A matches our answer closest. So that was number 13. Find f of 6 when f of x is equal to 7x minus 3. All right, so let's go ahead and plug in that 6. F of 6 is equal to 7 times 6 minus 3. So 7 times 6 is 42 minus 3. That gives us 39. That one should be cake. You should all get that one right? So 14 is A. 15. Determine whether a function is one-to-one. So we already talked about this. We had a question just like it. So to know if our function is one-to-one, we want to make sure that it passes the horizontal line test. Now, what's different about this one is that it doesn't give us a graph. But we know because we have the x squared, and we've seen that in past sections, we know it's a parabola shifted up 6. And it doesn't even matter about the shifts. We know it's a parabola. So a parabola does not pass the horizontal line test, right? So it fails the horizontal line test, thus it's not 1-to-1. So when I write 1-1, that means 1-to-1. So we say no. Okay, so this was our review for test 1. You'll have 15 questions. They're multiple choice. I was debating about creating an open response portion as well, but I think this is okay for our first test just because it's our first test. Next test, you'll have a second part where I want to see your work. All right, so again, this test is covering chapters 1 and 2. You have a week to complete it. You have 2 attempts and you have 2.5 hours to get it done. Now, it will be available to you maybe like in 10 minutes. Let me just make it available on Canvas. Once it's available, I'll send you an announcement. And I'm going to bug you with announcements today. I'm going to send you 2 announcements. And then I'll send you another announcement once this video is available for you to review in case you want to see it again, or for those of you who have friends who weren't able to be here, or for those who couldn't be here today, they can see it as well. All right, I'm going to stop the recording.